Hello, team. Ouch. This is episode 5. We're going to be doing greatest common factor and least common multiple. So we're going to do greatest common factor first and least common multiple. And here's some vocab I want you to know for greatest common factor. So, um, first word is factors, and factors are just whole numbers that can be multiplied to find a product. So like if we had the number 6, the factors of 6 are we can write them in pairs, like 1 and 6, because 1 times 6 is 6. Then we have 2 and 3, because 2 times 3 is 6. Like 1 times 6, 2 times 3, those both equal 6, right? So 1, 2, 3, and 6, we say are factors of 6. The next term is greatest common factor. We say GCF most of the time just to save time. And that's the greatest, and then in parentheses, biggest. So like the largest factor that is common to two or more numbers. And so we'll run through a quick example of that. So here it says find the greatest common factor of 12 and 36. And so the first way to do this is like this. So we can write both numbers out. Okay, so we have 12 here and 36 right here. And we can make like a T chart, I guess. And we list out the factors of each number. Okay, so everything that multiplies to 12, 1 and 12 for sure, right? 2 and 6 equals 12. We also have 3 and 4. And then we're done, right? Because if we go up to 4, it would just be 4 times 3. And that's the same as 3 times 4. So we don't even have to write that. So these are all the factors of 12. And let's do 36. So 1 times 36 for sure. We have 2 and 18. We have 3 and 12. We have also 4 and 9. And then we have 6. And we don't have to write another 6, but 36 is 6 times 6. Right? So we see that 36 has a lot more factors than 12, right? And that makes sense. 36 is a bigger number, so it's likely that more numbers can be multiplied to get it as a product. But the greatest common factor is the biggest factor that's in common between these two numbers, right? So the biggest number they have in common is 12. So we say the GCF of 12 and 36 is 12, right? And we can actually do this another way, okay? And this is called, wait, my thing stopped writing. Whoa. And this is called the cake method. So we write the factors. I am going to draw an arrow, sorry. 12, 36, and then we do this. We find a number that is a factor of both of these numbers, okay? So right away, I see 2, right? Because 12 is even and 36 is even, right? So 2 has to go in both of them. So we can put the 2 out here. And then we divide both of them by 2. So 12 divided by 2 is 6. And 36 divided by 2 is 18. And then we draw another layer, right? Because it's like a cake. And then what else comes out of 6 and 18? 3, right? I see 3. 6 divided by 3 is 2. 18 divided by 3 is 6, and then we draw another layer. And then what comes out? 2 again, right? Um, 2 divided by 2 is 1, and then 6 divided by 2 is 3. And then nothing comes out of 1 and 3, right? They're both prime numbers. So once we say that nothing can come out of the last two numbers, we see all the numbers on the side, and then we multiply them. We have 2 times 3 times 2, 2 times 3 times 2, and 2 times 3 is 6, and then 6 times 2 is 12. Right, so we're going to get the same thing regardless. And we could have done that in any order. We could have pulled the 3 out first. We could have pulled the 6 out, right? We could have, if we just saw 12, we could have pulled 12 straight away, and then we would have gone from 12 to 36 straight to 1 to 3. We would have skipped those two layers. So yeah, that's the cake method. Now you try to find the GCF of these two numbers. Okay, we're going to try a word problem really quickly for example 2. I'll type it on the screen so you can read it, but I'm going to read it out too. So UA high school students were asked to sit in equal rows for an assembly. There are 98 ninth graders and 84 10th graders. The grade levels were not going to mix, but the rows were supposed to be as long as possible. How many students should sit in each row? Okay, so we know there are 98 ninth graders, and then there are 84 10th graders. If we want to keep the grade levels separate, right, then we need to find the greatest common factor of 98 and 84, right? So we can see how long we could make those equal rows, okay? So let's do that. Let's do 98, 84. What comes out of 98 and 84, right? We definitely see 2 because they're both even. 98 divided by 2 is 49. 84 divided by 2 is 42. And then what comes out of 49 and 42? 7, right? 7, or 49 divided by 7 is 7, and then 42 divided by 7 is 6. And nothing comes out of 7 and 6, right? Besides 1. So we're done here. So we take the numbers on the side, and then we multiply them. So we do 2 times 7 equals 14. So we know that 14 is the GCF of 98 and 84, but it asked how long the rows should be, right? So we say that the rows should be 14 students long. Oops, long. And now you're going to try a word problem. Okay, so now we're going to do least common multiple, and here's some vocab for that. So, the first word is multiple, and that's just a product of a number and a non-zero whole number. So, like the multiples of 2 are 2, 4, 6, 8, 10, and so on. That's because 2 is 2 times 1, 4 is 2 times 2, 6 is 2 times 3, 8 is 2 times 4, and you get the point, right? A multiple of 2 is just 2 times anything. And the second word is least common multiple. We say LCM. And that's the smallest non-zero multiple that is common to 2 or more numbers. So example 1 for LCM is find the LCM of 3 and 6, right? And so we do it in a similar way to GCF. We can still make this T-chart. And then we'll say like multiples of 3. And then here will be multiples of 6. And then we can just list them, right? Multiples of 3 are 3, 6, 9, 12, 15, 18. Multiples of 8 are 6, 12, 18, 24, 30. I'll just stop there. And then the least common multiple is the smallest one that's in both of these columns, right? And that is 6. So we say the LCM of 3 and 6 is just 6. Cool. Now you're going to try one. Okay, so we're going to try a word problem. So here it is. Goku and Vegeta volunteered together at the same senior center. Goku volunteers every 4 days and Vegeta volunteers every 5 days. When will they be at the senior center on the same day again? Okay, so obviously they're not going to see each other that often, right? Because they're visiting at different rates. If we just think about it, someone who's going every 4 days and someone is going every 5 days, like they're not gonna like their schedules aren't gonna match up all that often, right? They're going at different rates. Um, but eventually they will, right? Eventually they are gonna meet up again on one day, on like a given day, right? And that's the LCM. So this is why the LCM is useful. So let's set up our chart. So let me just write here as a little note, Goku every 4 days, and then Vegeta every 5 days, right? And then here we have multiples of 4, and then here we have multiples of 5. Right, so let's list them. 4, 8, 12, 16, 20, 24. Then here we have 5, 10, 15, 20, 25. Oh look, and we already see one, right? We can just stop now. They both have 20, right? And it's the smallest one they have in common. So we can say that Goku, so we can say that Goku and Vegeta will see each other in 20 days. And now you're going to try a word problem.